Okay, so now that our ball is bouncing off the walls, we need to actually start it moving properly within our game. And to do that, we're going to create a simple script that will get our ball moving once the game starts. So we'll go into our scripts folder and we're going to create a new script. So we're going to go create C# script, and we're going to call this script ball controller. So as created, we're going to double click on it and it'll open up in MonoDevelop by default. And of course, you may be someone who has set up Microsoft Visual Studio is another good option for editing within Unity, but we're going to stick with the default system, which is MonoDevelop, and use that to demonstrate everything as we go through. So once MonoDevelop loads up, we'll be given this kind of default script file that Unity has. So just in case you've never encountered any kind of coding like this at all, and specifically coding within Unity, we're given these two different elements here that we can use within our game by default. So these are our start function and our update function. And our start function and update are, as these little bits of description here state, our start function is used as soon as our game starts, or B, as soon as an object comes into the world. So say in the middle of the game you brought a bullet into the game, for example, the start function that would apply to that bullet would only happen at the moment when it's brought into the world. So those are the two times that our start applies. And then the other default thing we have is our update, and our update is applied every instant of the game. So say you have a game that's running at 60 frames a second, for example. Your update that is being referred to here would be called 60 times during that second. So we'd have this running the whole time, and this is where the bulk of your action will happen with any particular game. So whenever you need anything to happen within Unity, generally speaking, most of the time it'll happen within the update loop. So if you have any timers counting down, or any regular actions, or if you're taking any input from the player or anything like that, that'll all happen within the update loop here. So we're specifically wanting to control our ball. So what we want to do is make it start moving as soon as the game starts playing. So we'll obviously need to start doing something within our start function here. But to be able to start moving it, we need to know how fast it should move, and we also need to know what's making it move. So back in our game here, we know if we click on the ball, the thing that's controlling our ball being able to move around within the world is the rigid body, and that's what gives us its velocity and its it's what applies the physics of Unity to the ball. Now obviously our box collider is what's making it solid, but all that does is tell Unity, okay, this box collider, say, is touching against this box collider, so now the physics should do something. So to be able to work out what it should do, we have our rigid body doing that. So what we need to do is we need to know what the rigid body is, and then we need to know how fast our object should be moving. So to know how fast our object should be moving, what we're going to do, above our start function here in this little gap, but below where we have public class ball controller mono behavior, so inside this set of curly brackets we have one opening bracket here and one close one down here. Just above all of that, we're just going to say here public float start force. So what are all these things here we just created? Again, if you've never encountered any kind of coding like this at all, it might be a bit confusing at first, but you'll see it's all made of very, very simple building blocks that add up together to make your games simpler than you would think they could possibly be, really. So we have at the start here, we have public. All public means is that we'll be able to interact with this thing that we're creating here back within Unity. So over here, for example, in our rigid body, we can see here there's a mass of 1 and a linear drag of 0. And the reason we're able to change these values at all is because they're set up as public. The other option is to set it as private. So a private float start force would mean that it wouldn't appear here in Unity and we wouldn't be able to interact with it. So we want to make sure that we set anything that we want to be able to set. So for example, we know that we want to be able to set how much force our object will have to start off with. We know we want to be able to set that within Unity. So that's why we make it public. So next thing we have is float. And float is basically a number value. So there's two basic types of number values within Unity. There's floats and there is ints. So what's the difference between them? Very simply and very straightforwardly, an int value here refers to integer, and what it is any kind of whole number. So it can be 0, 1, 2, 3, 4, 5. It could be a million, it could be a billion. But the important thing is it doesn't have any decimal places within it. Whereas a float value can have decimal places. So it could be 1.3, it could be 2.4756, whatever. It could be a billion point 3, whatever you want. But the point is that an int value can only be a whole number, and a float number can be any number that has a decimal point within it. So that's our first two bits dealt with here. And then finally we have this bit, start force. And start force is just the name that we're giving this float that we're creating. So we're creating a public float. So what we're saying is, okay, we need to have a number that we can use that has a number that we can use that has a decimal place within it, and we're going to refer to it as start force. So if I was to save this now and go back into Unity, we're going to apply this script to our ball before we do anything else, before we go any further really. You need to it's gone now, but we'll see it again, I'm sure, is when we save a script in MonoDevelop here, when we go back to Unity, what you'll see is a little circle spinning in the corner here, and that means the script is compiling, and once it finishes compiling, we'll be able to do stuff with it. So we'll come across that again very soon. But if we go to our ball here, we want to apply this script that we've created to it. So there's two ways to do it. We can go to add component and we could start typing in our ball controller script, and you'll see it pops up in the list here. Or what we can do is just click and drag. So we'll grab our script here and drag it over to add component, and just below it we'll drop it in there, and now we have our ball controller script there that we can interact with. And we'll see that the object we created, or sorry, the number we created back over here, our start force, you can see in our script here, we now have a start force value. So if we want to give this a number, say we'll give it a start force of 5, I think will be useful. At the moment it won't actually do anything, of course, because we haven't applied that in any way. We've just said, okay, here's a number that we're calling start force, and we can now interact with it here because we made it public within Unity. So if we go back to the script, just to clear up one little thing as well, over here we've created the value and we made it with a small letter to start with and then a big capital F in the middle of it. But if we look back in Unity, we'll see we have start force here, we have a capital S at the start now, and we also have a space in the middle of it, which we didn't write in when we created the name. So you might be thinking, oh, is start force like something that Unity would understand automatically? It isn't. It's simply the way we write variables, which is what this is now. It's a variable that we've created, and it's the way we write them within Unity. And it's kind of the common kind of way these things are written within coding, is to always start the word with a small letter, and anytime you want a new word starting, you make it a capital letter. So if I was to say start force number, for example, if I'm to save this now, go back into Unity, we'll see this little compiling, little kind of loading symbol or whatever you want to call it. And what we'll see now is it creates a space and then it says number. So basically any capital letter that you use here, it'll create a space before it within Unity, just to make it more easy to read for us as we go through. I'm going to delete that number there like that. So now we have our number value start force, and we know how it applies to our game here. But if we want to actually make our script move, what we need to do is apply it to our rigid body. So our rigid body is what makes it move within the world. And if we want to make any changes to the rigid body, we need to know what that rigid body is. So we need to create a reference to it in our script here. So what we're going to do is, unlike it being public, we don't need this one to be public. We're actually going to set this to be a private. We know we need to interact with the thing which is the rigid body 2D. So that's our rigid body 2D there. And we need to create a name that we're going to use for this variable that we're creating. So we're going to say, we're just going to call this my rigid body. Nice and simple. And all this does is creates an empty variable on our script, which is of the type rigid body 2D. So we've basically created, on this script here, we've created an empty rigid body 2D. We made it private so we can actually see it back in Unity here. If we let it compile, it'll compile away, and once it's finished, we won't visually see any changes here in our ball controller script. But there is a way to be able to see them, and it's a very simple thing and a very handy thing actually as well. If we go to these three little lines here, we've got some options we can use for our inspector, and we can hit debug here like this. And when we switch to debug view, that basically it changes how we view all the objects within the world. You can see we get some different options for our rigid body and for our sprite render and stuff like that. But what it also does is makes any private variables visible. So now we can see that my rigid body here is now visible, and of course it's empty because we haven't put any values into it at all. So we've got my rigid body, and it has none because there's no rigid body applied to it. So I'm going to switch this back to be the normal view because we don't really want to stay in debug view the whole time. And we're going to go back into our ball controller script. And now that we have our rigid body, an empty kind of reference to it, we need to know specifically which rigid body we want this to be talking about. So what we want it to be talking about is the same rigid body that's attached to our ball object within the world. So we have our ball controller script attached to it, and we also have the rigid body. So then what we can tell Unity, we can say my rigid body, which is the variable we just created up here, we can say that should be equal to, we'll use a function here called getComponent, and then we use a sharp bracket, and we say rigid body 2D, like that. And then we put two normal brackets at the end, and then we hit semicolon at the end of the line like that. So what is this sentence doing? So what we're doing here is saying, okay, the my rigid body, which is the empty variable we just created up here, what we want to do is set that to be the component that's already attached to the ball. So we know that this ball controller script is attached to our ball. So what we can say is get the component that is also attached to our ball that is of the type rigid body 2D. So it'll find the rigid body 2D that's applied to it, and it'll set that to be equal to this empty rigid body here. So this will be happening within the start function. So what we can do is check how this works in Unity. And it's important whenever you write any kind of code to make sure that it works as you're going through it. So don't ever write like 100 lines of code and then go back into Unity and then something small has gone wrong and you don't know what it is. It's important to, as you write code, test it constantly to make sure that it's all working. So if I go back into the game here, again, we can't see our rigid body in our ball controller script, so we're going to switch to the debug view once it's finished compiling. So we're going to go debug here, scroll down, and we'll see at the moment it's empty, but if we hit play, then as soon as the game starts, it'll read from the start function and it'll go, okay, set it to be the rigid body that's applied. So you can see it says ball here. That's because it's getting the rigid body 2D that's on the ball. So perfect, that's exactly what we wanted to do. And then the final thing we want to do is apply some force to make it move within the game. So what we're going to do is go onto the next line here, and we're going to say on my rigid body, what we want to do is say dot velocity. So what this means is we want to access the velocity of the rigid body, and we're going to set it to be a new value. So we're going to set it to be equal to a thing called a new vector2. So a vector2 is basically just an object with two numbers. It's got an x value and a y value. So because we're dealing with 2D, everything is only going to move on the x and the y axis. It won't be disappearing into the background at all. We're not worried about that. It's only moving either left and right on the x axis or up and down on the y axis. So on our vector2, what we're going to set this is to, by default, apply on the x axis. We want to give it the start force that we're going to apply to it. So we're going to say on the x axis we want it to be start force. So say if we had it be 5, we're going to say, okay, the velocity of our object when we start the game on the x-axis should be 5, so it'll be moving at a speed of 5 to the right. And on the y-axis, we're going to do the exact same and give it the start force as well, because it might as well be moving up and to the right when we start the game. So we're going to now save this. Before we go back into Unity, there's one more little thing we need to be aware of whenever we're creating scripts, and that's to make sure that any line that we create where something happens, so say for example on this line we've set our rigid body, my rigid body variable to specifically be the rigid body component. At the end of that line we need to make sure and put a semicolon at the end of the line. If you forget a semicolon, basically the script won't know what to do and it won't run in the game. And forgetting semicolons is probably the most common coding error that anybody does, and you are guaranteed to do it when you're making a game. It's one of those things that everyone forgets about sometimes when you're coding away, but it's a very simple thing to fix and a very simple thing to create. So basically, if you get an error within Unity, your first question should be, did I leave a semicolon out somewhere? So it's important to remember at the end of any line where you're making something happen, you put a semicolon in. So on these lines we're making something happen here, but on these ones up here, for example, the thing we're making happen is that we're creating an object within the game. So it's important to remember always to put your semicolons in place. So now that we've applied our forces to our rigid body, let's go back into the game here. Let that compile down in the bottom corner there, and then I'm going to switch this back to the normal view. I'm going to set our start force to be 5 like we had before. It got reset because I was changing the name of the variable. That's another actually important thing to remember. If you change the name of a variable, it will lose whatever value you've given it. So when I changed this to be start force number, it reset it back to be 0, and then when I set it back to be start force, it still remained at 0. But now we've set it to be 5, so let's hit play, and what we should see is our ball fly up in this direction and bounce off the wall. There you go, we got our ball bouncing just the way we wanted to. I'm going to just move it over to the side here just so we can get a little bit more action out of it than just bouncing off the wall once. But you'll see now that we've applied a force that will start our game, and we've also got it bouncing off the walls just the way it should be. So there you go, we've got our ball moving just the way we want. So let's start making it so that we can move our paddles up and down, actually start interacting with what the ball is doing.